Hey there everybody and welcome back to another Blender tutorial. Before I start this one, I just want to put a little bit of a note. I am so fucking wired. Okay, I drink too much coffee, so if I'm like bouncing off the walls in this tutorial, that's why. But we're going to be making a seashell in this one. I actually haven't really practiced this, so we're kind of do it live. But we're going to make a seashell procedurally because if you think about it, what a seashell is it's a spiral that you kind of randomize and color to look like a naturally occurring thing. And if you're a snail watching this video, I'm talking to you, Jared, we can build you a home. Before we start though, this video is actually sponsored by Squarespace, so I will get right back to the tutorial after this. Okay, so as I mentioned, this tutorial is brought to you by Squarespace, and if you haven't heard of them, it is the best, the most streamlined way to make a website. In fact, my website, www.cgmatter.com, made with the Squarespace template, hosted by Squarespace. It's just a great product that I use myself. So if you're looking to make a website, this is the way to do it. You don't need to know any HTML, any coding, anything like this. And there are 3 features that you might be interested in with Squarespace that comes natively, automatically. 1, analytics. Do you want to see who is going to your website, what demographic type information this is? Like, am I getting a lot of people from Russia? Then I can kind of make my website kind of geared towards this audience, or America, or one of these. Analytics is very useful for this. 2, do you want to embed your social media feed directly into this? So you don't want to redirect to Twitter or one of these, you just want to embed it directly in there. You don't want people to off-ramp to a different website, and it's important to keep people on your website. This is another feature that Squarespace has. And 3, as I mentioned, you don't need to know any coding or anything like this. You have automatic image cropping and block crop. It's Squarespace. You have a bunch of squares and you put them in their spaces. That's why it's so easy to use. Either way, if this is something you're interested in, head over to Squarespace, use your free trial to design your website, and when you are ready to take that thing live and make that moolah or spread your message or whatever it is, you can use the link in the description, my link in the description, to save 10% on your first purchase of a website or domain. Thank you, Squarespace, for sponsoring, and let's make some seashells. Okay, so let's get into it. We're gonna make a seashell, I guess. So delete everything, and then add in a cube, and we're gonna go into geometry nodes. So again, what is a seashell? It's basically a spiral that we fuck the ever-living shit out of, not in a physical sense, but in this kind of like mathematical sense. We're gonna fuck it up, add a lot of parameters. It's a spiral that we're gonna turn into a mesh, that we're gonna turn into a volume, and we somehow need to transfer parameters through all these. It's gonna be a bit complicated. So here we go. We're gonna start off with a spiral because that is the basis of a seashell. What I'm thinking is I want it to start off large and then kind of shrink as it grows, right? Or you could do the reverse. To do this, I'm gonna set the end radius to 0. So again, it starts at a radius of 1 and then it slowly tapers off. And let's bring the height down. To give this a bit of geometry, we're gonna do a curve to mesh. And by the way, if you want to follow along with this tutorial, follow along, great. But the main thing I want to emphasize that we're going to learn in this is how to transfer parameters between different types of data, like volume curves, all this. But okay, let's continue. So we're going to do a curve to mesh. We want to have a profile curve. I'm going to use a curve circle. And we have the basis of our shell. Does it look shitty? Yes, but we can fix that. One thing I'm going to do is I'm going to set the radius as we go along the curve. So I want it to start off thick and then it kind of tapers off in the same way that our radius is tapering off. To do this, we can use the spline parameter. Again, spline parameter tells us how far along the curve are we between 0 and 1. 0 is the starting point, 1 is the end point. And we're going to have it, right now it's going to be kind of reversed, if you can imagine that. So it's going to start off super thick, and then let me make this a bit more visible. It's going to start off super thick, and then it's going to end off tapering off to 0. So it's kind of inverted. So what I'm going to do is I'm going to use a map range, because we don't have an invert node for some reason, and switch 0 to 1 to 1 to 0. So as we go from outer to inner, you can see it gets thinner. We want the maximum radius to be smaller, maybe more rotation. So at this point, I'm just kind of shaping this to look more like a shell. And once you get something like this, I'd be pretty happy. So again, we're going from a maximum profile radius of 0.5 going down to 0.16. Anything else I want to play with? Not really. And don't worry about the fact that this is intersecting and it doesn't have thickness and all this. This is what we are going to fix by converting it into a volume and turning it into a mesh, like that. Do I want to fill in the caps? Yeah, I'll fill in the caps. Actually, I guess we don't, because we want it to be hollow in here. I'm going to set the end radius to be a bit smaller, set the height to be a bit lower. What we could do, we could get a bit fancy here, is instead of just having a linear height, we can use a kind of a curve function for this. So I'm going to set position. Every time we want to change the position of something, we use the set position node. And I'm going to offset on the z-axis. So the z-axis is going to be this one, right? And I'm going to make this relative to, again, the spline parameter and use a RGB curve. So what I'm doing here is I'm doing some kind of quadratic or cubic or some kind of profile curve to modify this. So I want to modify it going downwards. I want the top to go negative in the z, so I'm just going to multiply this by -1. Again, this is all a correction term. You don't need to do this. What I'm going to do is add in a bit of curvature, maybe like this. There we go. So this is what it looked like before. You can see it's kind of hovering, and then after, we've only taken the top or the end of the curve and shifted it down. And again, you can modify this by doing something like that. Just adding in a bit of variety. Another thing I want to do, just while we're here, before we turn it into a volume, is I can add a bit of randomness. So set curve radius, we can add to this. We can add either a random value or a noise or one of these. So I'm just going to add in a noise texture. And we want to normalize this. So I'm going to, right now it's outputting values between 0 and 1. I'm going to subtract 0.5. Okay, and then we want to scale this. So when it's set to 0, nothing happens. And as we add this, it's going to add a bit of variety, just making our shell look more organic. By the way, if we add a resolution to this, oh, don't worry about that. That was just the sound of the atmosphere. As we add a resolution to this, we're going to have more radius variety and stuff like this. By the way, fun fact, I'm making a pizza. Right, I'm not making a pizza. I just preheated the pizza. We have other people doing the work. Want to say hi? She does not want to say hi. I get it. I used to be the same way. So we want to add in a bit of variety, change the scale. I'm just adding in a bit of that kind of natural randomness and stuff like this. I'm going to set the end radius to something like that. Okay. We can modify this later. Either way, we now have a shape that kind of looks like a shell. We want to give it thickness. So what I'm going to do is I'm going to take, again, we started off with a curve. We kind of fucked up our curve and then gave it radius and then gave it thickness and all this. And now we want to convert it into a volume so that these pieces that are overlapping, they connect and it's one mesh. And we give it some thickness. So we have a mesh. We're going to do mesh to volume, which is a nice operation that just kind of turns this into a cloud. And then volume to mesh. And again, all of this is going to be procedural. Okay, so it looks like shit. That's fine. Let's save this temporarily. So seashell progress. Looks pretty good. And now what I want to do is kind of voxelize this in a way where it's not as rough and stuff like this. So I'm going to take the voxel amount. You can think of this as 3-dimensional resolution. Bring it up to like 200. And you can now see we're getting a bit more detail here. Do I want, we can make it a thinner band or a thicker band. So this is kind of the thickness of it. And also we want to bring up the adaptivity. That's going to kind of make it low res. I guess we can also smooth this in a sense by using a merge by distance. And we can merge anything that's within like 0.0 or 0.1. That might be a bit much. Divide by 2. And then we're going to do a shade smooth. And it's a bit broken, but you can see how we're kind of progressing here. Divide by 2. There we go. We have our detail back. I want this to be a bit thinner, so I'm going to divide. And there we go. So we've converted this into a thing that feels much more organic and real and all this. And we can always change the original parameters, like the maximum height and all this. So you can get different kinds of shells, like one of these or one of these. What are those? Whatever you want. Oh, by the way, cool little thing is because we're using a profile curve, you can make weird shells with like a square profile and stuff like this. Or even, I thought this was cool. You use a star and then you make it a bit thinner. And now you have like a shell that does kind of appear in nature, but you want to kind of give it a fillet and all this. A fillet, a skillet, I don't know. So we're going to do something like that. Now that I'm happy with the shape of the shell, and we can kind of go in this and like add more detail. So again, if you wanted to add a bit more organic detail, anytime we change the position, we use the set position. You offset it by noise texture using the color. And then we want to scale that with a vector math. So I'm just subtracting to normalize it. And then I'm using a scale operation the same way that we did the randomness before. So let's do something like that. So here I've added in a bit more randomness. You can do that if you want. I would up the detail and bring down the scale, but it's not too important. What is important is we now have a mesh that kind of makes sense. Like it has an interior, an exterior, and all this. Let me actually make it even more subtle. The rest of this is going to be in material, and the interesting thing about this is I want to have stripes progressing around the spiral, and because we converted this into a volume, it's going to be hard to transfer that information, so let me show you. What I'm going to do is I'm going to use a set material node. So we have all of this, and then we're applying a material, so that when we select our material, so I'm going to the shader editor, doing a material, we can call it shell. By the way, this whole project file, or the original, is going to be available on Patreon, so if you just want to download it, that's going to be, or maybe I'll also put it on Gumroad. In the shell material, you can now see if we go to rendered mode, and let's use cycles and all this, and maybe we'll use a HDRI. And I actually enjoy the volume workflow quite a bit, especially once we transfer attributes. Okay, so I'm putting this in kind of an outdoor kind of parking lot construction environment and all this. You can see that when I change the color, it's actually affecting this. I want to add stripes, or at least change the color as we progress along here, right? And what you might think is we can take an attribute and transfer it over. If we try to do that, right? So we take our original curve. I want to say, oh, store named attribute. We can call this spiral, and then we capture the spline parameter. You might think this would work, so let's see what it actually does. We use the spiral. You're going to see that it comes out black. And it's not that the attribute isn't transferring over, it's that it's for a curve, but then we're converting it into a mesh, and then we're converting it into a volume. There's no way to extract this using a store named attribute. So again, I want the gradient that goes from 0 to 1. So then what you might think is like, okay, that doesn't work. Maybe what we can do is, go to the step where we convert it into a mesh. So I'm going to store the spiral, and you can see that's already not going to work because as I'm changing the value, nothing's happening. But just to test, that's not going to work, again, because we converted it into a volume and it doesn't transfer over. So somehow we need to get from here to here after we converted it from a volume and back and transfer that information. So again, what I want to emphasize in this tutorial is when you convert into a volume, you lose all your attributes, right? And we somehow need to reclaim them. So what you might think is we use a transfer attribute node, and that is correct. What I'm going to do is I'm going to take our final mesh, or I guess, we also distorted and all this, but I'm going to take this mesh and this mesh. So remember, we have our original and then our volume converted one. And I'm going to kind of cast raise or transfer attribute based on proximity or distance or one of these. So what I'm thinking is we want to transfer from before we turn it into a volume. So we have this mesh. I want to transfer it from here. What attribute? We want to transfer the spline parameter, which we can capture. So it's going to get a bit convoluted. So we have a curve. I want to capture its spline parameter. I'm then transferring it over to the mesh. And then using a transfer attribute, we're going to say go from the volume, or the volume to mesh converted, back to the original mesh. So I understand it's confusing. We will get there. So I believe now if we do a store named attribute here, we call it spiral. And I guess first thing to notice here let's view the final mesh. First thing to notice here is as we increase the factor, it's actually doing stuff, right? Because we've already converted it back and forth and all this. So whatever we put in here will actually transfer. I want to transfer this attribute. And you can see what it does is it actually creates a gradient going from 0 to 1. It's not perfect, but you know, it does work. You could do this from the nearest or from the nearest face interpolated and all this. And we can smooth this out and stuff like this. But you can see this is actually transferring over. So what happened here is we have the curve. I captured the spline parameter. I then referenced it to the original mesh, and then we're transferring it based on proximity. And we can also do this, by the way, for our profile curve. So I know we're getting into the weeds here, but this is very important for the shading. So I'm going to do this. I'm going to use a... We'll see if we need to do a transfer. We might. I'm going to store named attribute. I'm going to call this spiral 2. So I'm kind of creating a UV coordinate system where one goes around here and the other one goes around our profile curve. And I want to capture this spline parameter. Let's see if that transfers over. So we have our first attribute, and then we have spiral 2. I imagine it would not transfer over for the reason we just described. So we need to do a transfer attribute over to this with the source. Basically, I'm just doing the same thing with a different parameter. And let's see if this works. And you can see that works. So we have a gradient that's black here, and then as we go around, it gets brighter and brighter and brighter. So again, all we've done here is we've transferred attributes from a volume. That's the key insight here. And this is useful for other projects as well. But the idea is now that we have both of these parameters, we can actually combine them to create a sort of coordinate system or a UV space or whatever you want to call it. I wouldn't call it UV space, but we take both of these, and now you can see we have our coordinate system, and this is all dependent on the spline parameter. So as we change the height and modify our shell, it's still going to keep that coordinate system. It's invariant in a sense, right? What this means is, let's say I had a checker texture, for example. If I try to map this onto the shell, it's not going to do a very good job. It's going to look super glitchy. But if I use our coordinate system, you can now see that it maps correctly. This is the core idea. And of course, we do have a bit of a glitchiness over here as we have areas where you transfer attribute, there's a bit of a discontinuity. One way to fix that is by adding resolution or something like this. Now I imagine the higher our voxel amount, the cleaner this is going to get. But you can see we can now transfer over information and shade our shell. So now the question is, what makes a shell look like a shell? So what we're going to do is we're going to use a wave texture. Wave texture, again, does not map correctly on any of these axes, but if we use our coordinate system, you can now see it spirals around. We are going to use, it's kind of up to you. I'm going to kind of use a diagonal. I'm going to add a bit of distortion, so I'm just adding in these lines of detail and all this, and making them rough. And what I'm going to do is I'm going to color this using our factor map with a color ramp. So a seashell, at least the one I'm going for, is kind of this tan color. So we can have the base of this be kind of like a yellowish kind of thing, and then we can have the dark areas be kind of like sand blasted or something like that. And we'll work on the colors in a second. So we have something like this. I think just generally we want to desaturate it. So something like that. And then the sandblasted areas, desaturate them, maybe make them a bit brighter. And you can see that this is kind of the makings of the beginning of a shell. We could get way more detailed here. We can add another wave texture, again, using our new coordinate system. And this one I'm going to make super, super dense just to add more detail. So I'm going to do this. Add detail, add roughness, add a distortion. And you can see we now have these lines, which we can do a cool phase offset for, by the way. But I'm going to use this to generate a normal map, is the idea. That's why I'm doing it. So I'm making this kind of very rough pattern. By the way, we might want to change our detail scale over here. Yeah. So I'm making a very rough pattern, which I can now use a bump node on in the height attribute. You can see it makes it a normal map, connect it, and now we have a shell that looks like more of a fossil kind of look to it, which I think looks very good, especially if we add a bit more distortion. Okay? And again, this is just the beginning of our thing. We can add way more to this. You could, if you wanted to, I don't think this would be correct, you can add subsurface scattering, so light kind of leaks through. I'd want to make it very shiny, because these are very smooth objects, right? And I want to bring down the strength of this, so you can kind of see the shine, maybe even add a clear coat. So you can see it's a shiny thing. And I think what's really going to sell this is the weathering. So I'm going to use an ambient occlusion node, which will calculate what areas have the most ambient occlusion, the areas inside, stuff like this. By the way, sorry for the fan noise. It's just, I'm not using my good microphone right now. We want to clamp this using a color ramp. So I'm making it really capture these areas. By the way, pro tip, if you use your normal map in the ambient occlusion, it will also reference that. So now you can see we have this weathered look. And what we can do with this is I'm going to take our color and I'm going to mix it with our gradient to kind of make a, well, you can make cool colors and stuff like that. I'm going to probably flip this and darken those areas. And that makes it look much more weathered. So you can pick what you want, maybe like a reddish, slightly brighter thing. You could even do some weird colors like blue and all this. I'm just going to pick colors that feel correct for the shell I'm going for. And remember, all of this is dependent on the spline parameter, so if I change, we could change a lot. We could do some weird stuff with this. So now we have like something that looks more like an antler. But you can get weird with the shells. You can add more curvature. So this is kind of like a thick shell. What did I want to change? We could make it have less spirals, more spirals, have it end thicker or thinner. You know, whatever you want. And I think the main thing to generate new shells is this height parameter, which will make it a tall shell. Now it looks like a pile of shit. But you could do all that. And I think that's kind of the essence of it. Again, make sure your voxel resolution's high. Otherwise, if you make it like the base 64, it's going to look super low res. So I'd recommend 200, if not 250. And yeah, I think that's the essence of it. Let me make this ambient occlusion a tiny bit darker. I think that looks really cool. And again, I just want to remind you guys that you can use any custom profile curve. So let's use a star and do that fillet thing. So if we actually preview the star, it kind of turns into this cogwheel looking thing. And we can smooth that out. And let's see what the final result looks like. It generates this cool looking shell. And we can modify it so that it looks like it makes a bit more sense. And if you wanted to get super fancy, by the way, if you do something like this with the star, you can add a bit of tilt. So set curve tilt the same way that we set radius. So as we change the tilt, you can see it's kind of, I guess let me do this in solid mode so you can actually see. It's kind of spinning around this mesh, which is a cool look. I want to tilt it by the spline parameter. And maybe to make it more evident, I'm going to multiply it. So maybe it's doing like 5 rotations. Okay, 15 rotations. Now you can really see it. And you get this kind of very ornate looking thing. But you can make different kinds of shells and stuff like this. So at this point, I think I've taught you everything about how to make seashells and stuff like this. You can make all kinds of varieties that look complicated. So thank you for watching this tutorial. Thank you, Squarespace, for sponsoring. And as always, at the end of these, I like to promote my Patreon. If you want to get the project file for this, not make it yourself, not spend 20 minutes, like just making this thing that you can download for like a couple bucks, Patreon's the way to go. You get exclusive tutorials. I've uploaded a couple months worth. You get early access to tutorials, any blend file I've ever made. And if you like what I do here where I make Blender tutorials for free, literally the best way to support it is via that. But other than that, thank you for watching, and I will see you on the next one.